Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on September 28, 2025, about 2 days ago. The headline result is that a specialized reward model family, EditScore, enables stable online reinforcement learning for image editing and even surpasses GPT-5 on its own benchmark. The paper is titled EditScore, Unlocking Online RL for Image Editing via High-Fidelity Reward Modeling. And as we will see later, the implications for model training are quite significant. Alongside EditReward Bench and self-ensembling, the approach lifts OmniGen 2 from 6.28 to 6.68 and adds 0.23 on IMG EditBench. Also, the authors shared a GitHub repo. You'll find the EditScore code and Python package, ready to run examples for scoring edits, quick start setup and requirements, example images, and evaluation utilities. There's an EditReward Bench evaluation with shell scripts, plus calculate statistics and evaluation code. Models and LoRa weights download automatically during the usage example. On Hugging Face, you'll find EditScore reward models with 7 billion up to 72 billion parameters, including 7B LoRa weights, code for scoring edits, re-ranking outputs, and RL fine-tuning. So, Table 1 compares the new EditReward Bench against prior datasets and shows it is larger and more comprehensive. The table highlights multi-dimensional evaluation, which means scoring edits along several axes like prompt following, consistency, and overall quality. It also indicates inclusion of proprietary model data, so the benchmark reflects what strong editors can do. Finally, task coverage spans subject, appearance, scene, and advanced edits, with all subtasks represented. So, while Table 1 set the scope, Figure 1 shows how expert labels are produced through a consensus ranking workflow. The key idea is tiered ranking, which means annotators group edits of similar quality into the same tiers so ties are explicit. This process yields clean, pairwise preferences, because only higher tier items are compared to lower tiers. The row of outputs illustrates diverse edits, and the boxes at the bottom summarize rankings into preference pairs. Well, Figure 1 showed how rankings are built. Table 2 compares reward model accuracy across models on EditReward Bench. Proprietary systems cluster around about 70%, forming a clear upper tier. Qwen72B lands near 61% overall and struggles on consistency. EditScore 7B surpasses that baseline, which signals the value of specialization. With self-ensembling, which means averaging several stochastic passes, EditScore 72B reaches about 76% and leads most categories. Alright, Table 2 set the accuracy landscape. Figure 2 shows that self-ensembling delivers better accuracy per unit compute than simply scaling model size. Self-ensembling means running several stochastic forward passes and averaging their scores to reduce variance. The colored solid curves rise more steeply than the gray dashed baseline, which signals stronger returns from extra passes than from bigger models. In practice, sharing the profiling work across the ensemble further improves efficiency, so the method scales smoothly across the 7 billion to 72 billion range. Alright, Figure 3 shows why the reward matters in practice. Panel A demonstrates best event selection, which means generating several edits and picking the highest scoring one, and the score climbs as N grows. Panel B contrasts reinforcement learning runs and shows stable gains when the reward comes from EditScore, surpassing a much larger Qwen 2.5 volts L model. Panel C illustrates that self-ensembling, averaging several stochastic passes, consistently lifts training performance. Alright, Figure 3 showed stable training with a better reward. Table 5 now reports the end impact on benchmarks. On G-Edit-Bench EN, the overall score rises by 0.40. Semantic control improves by 0.48. Perceptual quality lifts by 0.26. On IMG Edit Bench, the overall increases by 0.23. These gains indicate that reinforcement learning driven by EditScore consistently upgrades OmniGen 2 across both evaluations. Wrapping up, 2 takeaways stand out. A domain-specialized, high-fidelity reward model with self-ensembling finally makes online reinforcement learning for image editing stable and effective. And the resulting policy delivers consistent benchmark gains over larger general vision language models. The broader implication is clear. Reward modeling is the new bottleneck and lever. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.